Hey guys, it's Mr. Palmer. I'm back with a couple more review problems for work, power, and simple machines. In this case, we're going to look at problems 2 and 4. These both involved power. So these ones, we have an equation from an equation sheet. Power is work over time. So let's start with number 2. It asks us to calculate the power associated with the 600 Newton force that pushes a box 18 meters in 5 minutes. So we know that the force is going to be 600 newtons. It's giving us a distance, and it's giving us a time. Well, it hasn't given us work, right? We need work and time in order to get power. So we do have an equation also for calculating work, which is force times distance. So we're going to have to do that part first. So up in the problem, it gives us 600 newtons. So I'm going to write 600 newtons for my force. I'm going to multiply that by my distance, which is 18 meters. 600 times 18 is going to give us 10,800 joules. So that's the amount of work. Now we're going to substitute into our power equation. Power is work over time. We have the work, and the work is 10,800 joules. But the time has got to be in seconds. If I come back to the problem, it's giving us a time in minutes. So 5 minutes, let's do a quick calculation over here. We need to turn that into seconds. 1 minute is 60 seconds per minute, which is going to give us 300 seconds. So we're going to put 300 seconds on the bottom for the time. When we do the division here, that's going to leave us with 36. And what are the units? The units are watts. That's a capital W. Do not confuse that with work. Work also has a symbol of capital W, but this is a unit. So you're going to see it after a number. If you see a number that says 36 capital W, that means 36 watts, and that's a measure of power. Joules is the measure of work. The second one we're going to look at is another power problem. This one is asking us in this case, to calculate a time. It says how long. How long? This is time how long, right? What length of time will it take for a 4 kilowatt motor to lift 450 kilogram box 10 meters at constant speed? So let's think about that. Constant speed. If we're lifting at constant speed, that means this object is at equilibrium. The force in the upward and downward direction have to be constant. Our applied force is up, our gravity is down, so our applied force is going to be equal to the weight. So again, power is equal to work over time. If we're going to find time, that means we need to know power and work. So let's go back into our equation. 4 kilowatts. 4 kilowatts is a power unit. So we can put in the power. Power is 4 kilowatts. That means 4,000 watts. We need to get the work. Well, it doesn't tell us work, but it does, again, give us some information. 450 kilograms is the mass, and we're lifting at a distance of 10 meters. Well, work is equal to force times distance. In this case, since we're lifting it, the force is going to be equal to the force of gravity, which is the weight. So we can do mg times d. So the mass was 450 times 9.8. That gives us the weight times the distance we're going to lift it, which is 10. We multiply that together. It gives us 44,100 joules. So into our equation, we're going to put 44,100 joules for the work divided by the time. We have to do a little bit of mathematical rearrangement here. Multiply both sides by t. T cancels out. Divide both sides by 4,000. And then we're solving for t. So 44,100 divided by 4,000 is going to give you a time of 11.0 seconds. And that's how we solved it. I'll be back with part 3 to finish up with simple machines next.